Hello everyone, welcome back. Let's continue our journey to learn Go. Today I'm bringing three subjects for us to learn, which is arrays, slices, and maps. Let's go. So just before we start, just a friendly reminder that this is Go by examples. We are learning through taking a look on examples, executing them, and seeing the results. Those examples are being taken from a website called gobyexamples.com, which is also available on a GitHub repository. You can clone the repo and you can follow along. The description of the repo and the website will be on the video description below. And yeah, okay, let's just take a look. So first of all, before we go to the examples of array, let's just make sure that we have the latest version of the code. So what I'm going to do here is just do a git pull. I do have the latest version and should be already up to date. So what you're going to do is just try to find the file arrays.go within this repository. Should be located under examples, arrays, and arrays.go. There are several examples here, a lot of capabilities that we are taking a look here on what can it be done with arrays. So just for the sake of our learning, we're gonna go as usual top to bottom, and I also want to execute first the code so we see the output and we can compare the output as we go. So what I'm gonna do here is open the terminal, then we go to the folder called examples, arrays, and what we're gonna do is a go run dot. This will show the output, and yeah, let's just take a look at what it means and like what we are trying to learn here today on arrays. So at the very top, in Go, on an array is a number of sequence of elements in a specific length. This is an important thing to notice. Is different from other languages, or actually similar to other languages. When you're using an array, specifically on Go at least, you got to predefine the size. So if you want to work with 10 elements, you have an array that is 10 elements. It cannot grow in size and it cannot shrink in size. So you predefine. That makes them a little bit less flexible. That's in Go. There is another subject called slices, which we'll discuss here today. But let's just continue. Keep that in mind. So here we create an array A that will hold exactly 5 integers. The type of elements and length are both part of the array's type. By default, an array is 0 valued, which for int means 0. So let's just on the line 14, it declares an array and it's 5 elements, and we did not assign anything. And when you print it, you see the result here being just 5 zeros. That's what it means by default. So even though you do not specify any value, 0 is a value by itself, right? So just have that in mind when you're using arrays, that you're gonna have the default values of that object. If you're working with structs or strings, they will have the default equivalent. But yeah, just very simple so far. And in terms of continue here, you can set a value by specifying which element you want to set. So in this case here is the 4th element. So we are assigning the 4th element, actually, sorry. The index 4, which is in fact the 5th element. We got to start with zeros, right? So we specify the 5th element, the index 4 as the value 100, and then we print. As we can see here is the actual 5th element, which is the 4th index of the array right here. And another one is how you actually get a specifically value. You just specify the array and which index you want to retrieve the value, and we print that, and it's 100. We just specify on the previous line. Now let's continue here. There is a built-in len, which is to return the length of the array. So in this case, you just say len a, and you just say 5. And this is a tricky thing that I wanted you to keep in mind is even though you declared 5 elements, you only use 1, right? Like you specify 100 here on the 4th index, but there is 5 because, that's the amount of elements it's declared as part of that array. So it's not as easy to count like, hey, tell me how many elements is populated. That'll be in somewhere else, like slices, for example. But yeah, just keep that in mind. So yeah, the length will always be the size of your array declaration per se. So let's continue here on the line 29. So this one right here. So use the syntax to declare and initialize an array in one line. So as we've seen before, you have this syntax right here, which you have the colon and the equal sign. You predefine the value of the array, the size, which is in this case is 5, and you can declare and assign values right away. We just, in this example, assign 1 to 5, and then we print it. So we should see here 1 to 5, and that's pretty much it, right? And then here, last but not least, to show us array types are one dimension by default, but you can compose types to be multi-dimensional. So in this case here, we are declaring our array, which is a multi-dimensional array. So we are saying, hey, there will be 2 elements on the first dimension, and each element will hold 3 other elements. And we have a for each here, a specific logic to dynamically populate those elements. We can actually debug just to see it, even though it's a simple code. It will show us how it actually looks like. But let's just see here the result first. The result of this 2-dimensional is there is a bigger array here. Like actually, this structure just shows that you are printing an array, and then the first array is 0 to 2, so 0, 1, and 2, and the second one is 1, 2, and 3. Let's just take a look here real quick, just to make sure how we see those arrays. Here we go. So the 2 element, as soon as you declare, you're gonna see here on the variables on the left side, and you can see that is a multi-dimensional array, but you already assigned in memory that you want to hold that values. And we know by now that when you declare an array of integers, the default value is 0. So you see a multi-dimensional array that is showing all zeros right now. So as you go through, so we're gonna assign, in this case here, it would be I plus j, which is both are 0 at this point on the first dimension of the array here, and the second one. As soon as you do this, you're gonna see here on the left side, actually didn't change because it is still 0. But if we continue here, this other one here changes to 1, right? On the left side right here on my mouse. So you continue, and the next one will change to 2, and then it will go to the next array on the second index of the first, on this multidimensional array. And here we'll change the value to 1, and then we'll continue to change the value to 2, and finally change the value to 3. So that's pretty much it for arrays. Arrays is actually very simple by nature, but they are very inflexible, and there are just certain use cases that we can use them effectively. But you're gonna see in Go, the majority of the time we're gonna be using slices, which is the next topic. Let's go. Okay, let's take a look on slices. So in order to do that, let me change to the File Explorer once again here on the left side. And then we're gonna go up one folder. We're gonna open slices. I'm gonna clear this terminal, and we have a clean one right here. Let me just close the terminal for now. Actually, before closing it, I actually prefer to run. Let me change the file here to slices.go. There we go. And let's just run first. We leave the outputs here, so will guide us what we are trying to produce, right? So let me just put it a little bit more up, because there are more output. Here we go. All right. So the slices are a key data type in Go, giving a more powerful interface than sequence than arrays. They don't explain why yet, but if we continued here, you see, unlike arrays, slices are typed only by the elements they contain, not the number of elements. That's the difference. So you don't need to predefine the amount of items or elements you're gonna hold in a slice, it's essentially, you can increase and decrease programmatically. So to create an empty slice with a non-zero length, you use the built-in make. Here we make a slice of string and length of 3. So it's just a way of declaration, right? So instead of you're declaring an array on the size of 3, you just say, hey, I want to make an array. I make a slice, and I will predefine the size as potentially having 3 elements. So just before we go forward here, I want to mention a few things, okay? So number one is, I think a slices is just a fancy term. In other languages, this will be just an array. So in a sense that other languages, they refer array like either as a hard-coded amount of elements or just dynamically. You can increase or decrease it. Some languages, they allow to do that, right? Some other languages, like high level languages like C#, most of the cases they are using like generics and lists. If you're unfamiliar with those terms, that's okay. But it just should allow you to work with like multiple elements and growing size and reducing size. But here in Go, they wanted to make the distinction very clear, so they changed the name. So every time you're dealing with an array of dynamic size, we call it slices. So just keep that in mind. It's just a terminology thing. Okay, so let's take a look here. What is doing here? So it declares a slice that is capable of holding 3 elements, and it prints the slice. But look at the difference here, right? So here, even though its string is empty strings, right? So it's not printing anything at this moment. And then if we continue here, we can set each element individually. So it's setting the first, the elements index 0, 1, and 2 with those values, and then we print, and only then you can see A, B, and C. Very similar, like so far syntax-wise, you cannot tell that this is an array or a slice, right? That's the catch that I wanted you to keep in mind. And then like the way you retrieve a single value is just by specifying here on the brackets and the index element, and we print that value, which is number is letter C right here. Yeah, okay, letter C. So just continue. So the length returns the length of the slices as expected. So far we have 3 elements on this slice, and here we go, we know that it's 3. So a length is more useful on a slice because it's dynamic, the size. In an array, if you declared, you already know what's the size. So now we're gonna start seeing like the difference between slices and arrays is the capability to grow in size, right? So right here we have a function which is a syntax on Go that is called append. So you pass an array, in this case a slice again, and then you append to a new value. So in this case, you provide the slice is a slice of string, so the value when you append must be a string as well. So when you do this, it returns a new slice. That's why you need to have a equal sign here. So you have the previous slice and say, hey, I am equal to the result of appending itself plus a value. So when we do this, and then you have basically a new array with a new memory, like a new memory allocation and everything. So we continue here. You can actually have a dynamic way to add multiple values at once. So instead of just adding a single value, you can add multiple, like this one right here, and you will have the same outcome. So far on this array slice, we have A, B, and C. So we are appending letter D and then E and F. It's appending in order. So when we print this on the terminal, you're gonna see that it's actually A, B, C, D, and F right here. So just continue here. Slices can also be a copied. So here we create an empty slice of C with the same length, and we copy into from the slice S into C. So this is an important topic because If we didn't have this capability, it would force us to declare an empty array slice and do a for each, or like a for loop, and just copy over. But instead, Go give us this capability by default on the framework that you can just copy it over. So first, in this example, we are declaring a slice C with the type being string, the elements, and the default size is whatever the size is right now on the slice S, which so far is 6 elements. So once this is declared, we can copy over. The first parameter is where you want to copy to, and the second one is the from. So once you do this, you print, and you're going to be able to see the exactly same value output. Just continue here, and this is starting getting interesting on slices. On the top of having, you know, the copy mechanism, and there is other things as well, it provides a slice operator. With this is a syntax where you can slice a portion of a slice. You can slice a portion of an array, let's just say that. So if you have a slice of 10 elements, but you just want a portion of it, just the center, just the middle, or just the end, or just at the beginning, you can use this slice operator. And I think that's why they baptized this name as slice, because it gives you the capability to slice portions of it, I guess. So here's what it does in this example. The slice operator is the column. So what you do is the syntax is the low column and high, meaning I want it to start on the element 2 and finish on the element 5. When you do this, in this example, it will show 2. You know, you're getting the value from the space index 2, 3, and 4. But let's take a look on the output. Look at this. It will print C, D, and E. We know there is 6 elements right here. And this is what I find it confusing, okay? And personally, I think this is a flawed design on Go. Others may disagree, or maybe there is a greater good of example of why they decided to do that. But pay attention into this. When you say 2, right, is the element 2, so like 0, 1, and 2, which is the third element, right? That's why you're starting on C. But when you say on 5, it gives you the idea that is like the 5th index, right? The same way that you started here. But the answer is no. It is 1 minus that one. So what it basically says is excluding. So the low is including the element, the index 2, and the high is excluding that value. That's why it's getting up to 4, right? To me, when I see this code, I automatically think that would be something like this and 5, but it's not. So yeah, keep that in mind. The applicabilities of this, you know, slice operator, I have a feeling that it will not be much into like, you know, default business logic, you know, you implement it on a finance application or an e-commerce, but this will mostly likely be applicable for like lead codes or some like, you know, coding test. But I may be wrong. Maybe I'll continue to, one day I'll face a situation where I need to use this. I don't know. We'll see. But yeah, so that including, excluding is a little bit more explained here. So for example, on the slice operator, you can omit the low and you say, hey, I wanted to slice up to that element, but excluding 5 in this case. And then we print, and we see here is everything, the A, B, C, D, and E without the letter F. So you're excluding. And the same thing, if you specify the low, but you don't specify the high, you're including, right? So in this case, you're starting from the element 2 and pretty much all the remaining elements. So we are getting the letter C, D, E, and F. So just, you know, not showing the A and B. So yeah, that makes sense. So yeah, keep in mind slice operator and the including and excluding. Just keep that in mind. All right, let's continue here. We can declare and initialize a variable for a slice in a single line as well. Yes, so the same way that we did before with arrays, you can specify, the difference here is you do not predefine the amount of elements that this will hold, which will automatically make it as a slice. So in this case, is a slice of strings, and you specify the values G, H, and I. And when you print this as declaration right here, you have G, H, and I. So let's continue here. So the same thing as arrays, you can also have multi-dimensional slices. In this case, slices can, what's written here is slices can be composed into a multi-dimensional data structures. The length of the inner slices can vary, unlike the multi-dimensional arrays. And this is an important thing, right? So look at the output. We have a print right here with the two-dimensional array, and the variable that we're using is called 2D. Look at the output. So it is an array, right? And the first element of that array, it is also an array, but the first element is just just 0, so only one element. The second portion of that multiple dimension array, which is also an array, has 2 elements, and the third one has 3 elements. Why am I emphasizing this? Because on the declaration, look at this. On the 67 line, we are declaring a multi-dimensional slice with 3, and we're specifying the actual size here. But this size is only for the first portion. That's what I wanted to stress. It's just for like this first right here. That's why we have 1, 2, and 3 elements, which each of them is an array. And then what it does is it goes for each of those elements, and for the inner array, for like, you know, the second dimension of that array, we make a new one. So for the first one, it will make with like only one size. The second one will make in 2 sizes. Let's just take a look. Will be better. So it'll be right here. Okay, here we go. So we'll declare, right? Okay, let's take a look here. So look at this. So right now it's declared, but there is only 3 elements because we specified the elements, and each element is also an array. But look at that. The array so far has the child arrays has 0 length, 0 capacity, and it's nil. It's null. There is no value, right? So what we continue to do here is we have the inner array, which will be 1, and we make a new one. We say, hey, this inner array, I wanted to make a new slice, and the size of that new slice will be 1. So as soon as you see this, look at this. Look on the 0 right here, right? So we do this, and it changes. It now says, hey, the first element of this multi-dimensional array, it is an array, but now has a value, and it's only 1 dimension. And so far the default value is 0. If you continue to go here, we'll try to change the value, and this the first one will be indeed 0 because I plus j, in this case, they are both start at 0, so that's okay. And then we go to the second multi-dimensional portion, and we make another one. Right, but in this case, it's because it's dynamic, we're making the size of 2. So if you go here on the left side, you see that now we have 2 elements that can possibly hold values, integer values. So we continue to go in here, we assign the first one as 1, and the second one will be 2. What happened there? Visual Code, you don't like it. All right. So you continue to go here, and then the last but not least, we'll make the third element of this multiple dimensional array also an array that holds 3 values, right? Slightly confusing at first glance, but it is actually very simple, to be honest. So yeah, so it will be the value 2, 3, and 4, and we finally print those values as an output. It should be on the debug right here. Here we go. So let me just stop this one right here. So I have a recap, right? So this go by example, series that we're doing. We are just taking a look on the very basic capabilities of Go. Slices is actually much more complex than that. It has many other capabilities, and the way it handles the memory, the way it slices, it's very much like a low programming languages in a way that gives you a lot of different capabilities. But that's a more intermediate to slightly more advanced topic, and I think I would like to make a video only about that. But for the sake of this go by example, video that we're just seeing the basic capabilities, we learn the basics by knowing how to declare a slice. We understand that a slice is essentially arrays with dynamic sizes, and as such you're gonna see most of the cases gonna see slices in Go projects than arrays. You barely will see any arrays. Yeah, so we learned the basic capabilities, and I promise in the future I'll release a video just to talk about more details on slices and some more other magic that can be done with it. And now let's go to the last part of our video, which is maps. So I have the maps open right here, so just click here on maps. I'm going to open the terminal here and clear what we have on the previous one. We enter in the folder maps, we clear it again. As usual, we will run the code, right? So let's just run what we have here, and we have some output. Let's take a look top to bottom. So maps in Go are a built-in associative data type, and there is a Wikipedia link, and some other languages called hashes or dictionaries and dict in other languages. And I've been working in software development for 15 plus years professionally, and this is, as my memory tells me, that this is the first time I see that is the actual name for this type of arrays, which is associative data type. To me, it was always dictionaries. My background in programming languages are basically C# and Java, so when I see this, it's kind of nice. So yeah, dictionary. So I'm gonna put here on the side what a dictionary is just a way to show you that you can have a slice that holds a key value pair, where so you can dynamically specify the key and then you specify the value as well. The way that we declare is very similar to slices. We leverage something called make, the function for Go. Yeah, so let's just take a look here. So to create an empty map, you use the built-in make, and then is a key value type. So we are making a map that holds keys of strings, but values of integers. So, and here next, what we do is we don't need to do append, because that's not how maps work. You just go ahead and specify a value right away. So in this case, we are saying that the key K1 holds a value of an integer 7, and a K2 holds a value of integer of 13. When you print this, it shows very nicely, actually. It shows, hey, this is a map, and within this map, there is so far two combinations. The first combination is a key of K1 and the value 7. The second one is a K2 and the value 13. It just continues to show how we retrieve those values individually. So you can assign a variable and take the value from the map on the value that is inside the key of K1, which is this case 7. And then same thing as arrays and slices, you have the capability to do length. So what's the current size of this dictionary? The current size of the dictionary is 2. Clearly, this is a dynamic length like capabilities, same as slices. So as you add keys in value pairs, you'll grow in size. Another one here, another nice capability is the delete. So the built-in delete removes the key value pairs from a map. So you pass the map and say, hey, I wanted to delete the element that contains the key K2. And then once you print it, you're just going to see that now we only have K1. So the K2 with the value 13 is gone. Here's another thing is the optional. Yeah, this is. Let's just take a look on the line here. It's introducing something new that didn't show it before, which is called this little syntax here is an underscore and a comma, and there is another value here that doesn't need, as far as I know, doesn't need to be PRS. This is just an example, but this syntax right here, I want you to understand is there is a few functions or a few things in Go that returns 2 or more values, typically 2. So when that happens, you can use a comma. So a comma, you automatically assign the first return to the first portion of the variable, which in this case is an underscore. I'm going to explain that in a second. And the second one is the second return, and you assign into that variable. We are using the colon equals sign, so you don't need to specify what's the actual type. But if you mouse over here, you see that this is a Boolean. And if you mouse over here, you see this is an integer because this particular map M, it's returning values of integers. Now, what I want to tell you is this, what does it mean, the underscore syntax? In Go, it's called blank identifier. A blank identifier is just a safe way to discard a value that you don't want to use, you don't need to use. So for example, it's not because this syntax is returning 2 variables, you're going to use both of them. If you only need to use one of them, you can use this underscore sign and Go will optimize the code so you don't need to use that value pretty much. So it's called blank identifier. I'm going to leave a link on the description directly on the Go website, official documentation that explains this in a little bit more detail in case you're curious. But yeah, so why a map have this syntax? Why in a map you can do an equal sign in this? It just should tell you the capability to understand, hey, is this key exist, right? Remember, we just remove a key here, right? Remove the key K2. So what it's doing is telling the dictionary, hey, dictionary, I want you to tell me the value of K2 and assign to a blank identifier, meaning we are discarding. And the second one is returning, does this key value pair exist, right? So that's essentially what it means. So because the answer is no, we just remove the K2. This will be assigned as false. So when you do this, you'll just do as false. Other high level languages, they usually do like contains or, something along those lines. But here in Go, the syntax we do before trying to, add business logic to the value, you check if the key pair exists first. Yeah, that makes sense. It's very straightforward. So yeah, let's continue. So you can declare, initialize a new map in the same way. We can declare pretty much anything in Go. So you specify a map with a colon, a equal sign, and you say, hey, this map will be a key of strings, but the values will be integers. So, and you can specify the values right away. We are seeing here foo, which is value 1, and the second key, which is bar and the value 2. When you print it, you see bar 2 and foo 1. I do see a lot of applicabilities on maps. One example is like, states, and in a country, in the United States, you have like the normal name like California, but the shortened version of that state could be CA. So like, if you want to have a slice, array, or map to hold this kind of value, maps would be like the most suitable, likely the most suitable, variable type to hold in this case. And yeah, that's pretty much it for today, everyone. I really appreciate your time. If you're liking the content, please like and subscribe to my channel. There will be more videos coming, many more exciting things on Go. I hope this is very exciting and informative for you, and I really appreciate your time. Thank you very much. See you next time.